Okay, so today we're going to explore the FIFA 19 complete dataset. We're going to do some graphs, some visual analysis, some machine learning algorithms in order to predict market value of football players or soccer players, if said in the United States. So I'm just going to briefly introduce the topic. And so yeah, I'm going to be working with a dataset that contains the complete FIFA 19 dataset of the football players that are contained in this video game. And the dataset was extracted from Kaggle. I'm leaving there a link in my README file so you can access it. And the codes were done in RStudio. So why do I think this is relevant? This is relevant for hiring managers in order to take better or take more informed decisions on who to hire or who to sell in transfer markets. When we're speaking about footballers, there's lots of there's millions actually of dollars that are being spent year to year so that clubs contract or hire footballers. So as I said, some of the challenges are that there's lack of specific information for hiring managers in order to hire the best possible players for a specific team, and they also can do inadequate pricing. They may pay too much for a specific player that under delivers in the pitch, or that they may sell a former player for a very low price. So being said that, the objectives are mainly two. First one is providing insights of the complete dataset, having a big picture of what of distributions of soccer players as well as teams, and we're also going to create some models, machine learning models, to get accurate market predictions for footballers. The workflow is as follows. We're going to do a 5-step process. We're going to start the data cleaning. We're going to get the data tidy so we can work with our variables. And then we're going to do some exploratory analysis, some cool graphs in order to portray interesting facts about footballers. Then we're going to explore the top 10 facts about the FIFA 19 dataset. I think this is a great way of getting to know more about a project or a problem, is that portraying 10 facts about it. Then we're going to do a case study for Manchester United. We're going to end up with 5 players which we're going to recommend for the manager to hire, and we're going to do predicting market value with machine learning models, really sophisticated and cool models, which we're going to run. Okay, right, so first step is the data cleaning step, and before we start we want to download the libraries which we're going to use. If you want to have if you want to look more into detail to the codes I did, you should look at the repository and look at the coding section. I uploaded a script file. So we're going to set up our working directory, and then we're going to extract the data. And a useful function is to view the dataset with this specific function, which is the view function, and we're going to see the first columns of our datasets, and it looks like this. There's a player ID, the name, the age, and so on and so forth, many columns. And so we're going to want to know what is the dimension. That means how many observations we have, how many rows we have, and how many columns we have, how many features. Is another way of saying it. So we're going to have a total of 18,207 observations and 89 columns. This is a pretty big data set which we'll be working with. And so these are the variables. I'm just going to name a few: age, nationality, overall, potential, club, value, wage, preferred food, international reputation, weak food, skill moves, and much more. And so after knowing what are the columns or the names of the features we're going to see how complete is our data. And actually this data is pretty complete. It's pretty has a lot of quality in the way it was portrayed, and there's only 0.001% of null values. If you want to take a closer look, just look at the script file. And what will we do with those missing values? We're not going to get rid of them. We're going to just impute them by assigning the mean of the column, and that's what we're going to do. We're going to do some mean imputation, and then we're gonna get rid of some unuseful variables which are not gonna be, as I said before, useful in order to draw some conclusions and graphs, and yeah, they're just not gonna be useful. So we're gonna get rid of the flag. The flag comes in a specific code which we're not gonna use, the ID, the club logo, and columns 29 to 54. That is what we're going to do. And so yeah, and we're also going to remove some unuseful characters. They're unuseful because we're not going to be able to summarize the table, to portray some cool visualizations, to do some modeling if we have certain characters such as a $sign, or in this case it's a euro sign. But you have to get rid of these types of signs. You see, it's like the $sign, the millions, periods, commas. You want to get into your model and into your graphs just only numbers. And we're going to transform some text variables also into numeric. We do that by encoding them, and here's the code. So in the end, we are going to finish the cleaning section, and we eliminated some columns and we modified other columns, but we're also going to create a new column, a new feature which is called potential gap, and this is feature engineering, and I just wanted to do this for further step that we're going to do afterwards. And so yeah, I wanted to create a variable which is called potential gap, which is the difference between the overall performance and the potential of a player. So this gives us an interesting variable which we'll be using afterwards. Yeah, enough of data cleaning, and now let's start with exploratory analysis. Exploratory analysis, basically what we want to do is to explore our data. We want to get some graphs, some insights. Oh, here am I. We want to get some insights about the population or the sample that we have here. So yeah. So we're going to, first of all, we're going to plot how our the overall performance of players, how is that distributed? And that is distributed in a normal distribution fashion, which means that there's a big concentration in the middle values, and there's few excellent players as well as very few not so good players. And here we have the summary statistics. So the maximum score is 94, which probably is Ronaldo's or Messi's score, and we do have lots of concentration between the 60s. So the mean is 66.24, and the minimum value, which would be for a almost amateur player, is 46. And after that, we want to know how are ages distributed. And this is pretty interesting because before doing this, I thought that ages would also be in the normal, would take a normal distribution, but it turns out that it's more on the left side. Okay, so football players tend to be young. It's a young profession, and the mean is 25 years old, but the maximum is 45. Someone like how can I say this? I would expect that the mean would be closer to the 30s, but that's not the case, and that's pretty interesting, and that's a cool insight. And so we're going to also draw a bivariate plot, and we're going to see how does rating affect as players age or have more years. So this is quite interesting, but it's also quite intuitive in the sense that when professional footballers start being professional, the first years they don't reach their peak level, but they do reach it at just be close to their 30s, 30 something. That's where they reach their potential, and then after when they reach an age which is probably 35, 36, then the level starts to decline. So that's pretty interesting. Now I want to know I want to get some statistics on teams. So I want to know which are the oldest teams and which are the youngest teams. So part of this plot was extracted from Kaggle, and I did some arrangements here. But so we have the oldest teams and the youngest teams. The oldest teams average 31.6 of age. That is the oldest team, which is Paraná, and they're on the 30s, the oldest teams. And interestingly enough, they're from Brazil. But the youngest teams average way less age. So the youngest team, professional team in the FIFA19 is 20 years old. That's pretty young. That's below average. So there's many explanations for this, and one explanation which I can think of is that Brazilian players tend to retire in Brazil after long careers in Europe. That fact is key to understand the above average age for some of the Brazilian clubs. That is one specific answer I can give. And also young average teams tend not to have a large budget to spend on mature teams, and as soon as their players gain experience, they are sold to big clubs. That is why these clubs here, which are not I wouldn't say they are top clubs, they can be conceived as early exporters, because they're pretty good at building talent but not so good at retaining them. They probably have a financial strategy in order to sell some of their most talented players to bigger European clubs. And now I want to know which are the highest overall rated players. And the highest overall rated players, and I'm going to put this in purple because this is pretty interesting. The purple are the Italian teams. They average the best overall score in their football players. Well, that's pretty interesting because I wouldn't have thought that before doing this, and that makes me think that they have their variance between the quality of their football players is not very big, and they're concentrated into above average scores, but that doesn't mean that they are the most talented. If we look at which teams have the most talented players, the ones that have more superstars. Superstars would be defined as those that have more than 85 score overall. They are not actually Italian teams. We have in first place Real Madrid, which has many superstars, like they used to have Cristiano Ronaldo, Luka Modric, Sergio Ramos, and other quite good footballers, as well as Manchester City. But the Italian teams don't necessarily appear in the first places. You also have Barcelona, Bayern Munich, and that is a very interesting fact. And now I'm going to speak about the top 10 facts about FIFA 19 dataset, and this is accompanied by some cool gifs here, which I embedded. And I wanted to do this because I think this is really appealing. It's really appealing to see, to portray facts in this fashion, in a fashion of a top 10 about something, right? So, fact number one is that the total left-footed players in the game is 30%. So 1/3 of the players are left-footed. Fact number two is that the country with most players in the game is England, followed by Germany, Spain, Argentina, and France. The reason why England is in first place is because the game does not only have the Premier League but has the other divisions, the second division, third division, fourth division. So that's the specific reason. The nationality with most top 100 players is Spain. It has 14. It has really top players playing not only in the Spanish Liga, but also in the Premier League and in the Bundesliga, which is the German league. The oldest player is a Mexican player. He's a pretty good player. He's called Oscar Perez, Oscar the Bunny Perez, Oscar el Conejo Perez. He is 45 years old, and he just retired last year. And the best 5 under 21 players in the game. Well, the first one is clearly Kylian Mbappé, which was the superstar of France being the world champion, followed by De Ligt, which is a defender that now plays in Juventus, Donnarumma, which is an Italian goalkeeper that plays for Milan, Marcus Rashford, who plays for Man U and is perhaps the star right now, and El Bailey, which I don't know who he is, to be honest. And England's best rated player is Harry Kane, superstar from Tottenham. The average player age in the game is 25 years old. That's also really interesting. I'm more than 25 years old, so I wouldn't be an average age player. That makes me a bit upset. There's a total of 652 teams, and the best 3 players Number 1 is of course Lionel Messi, number 2 is Cristiano, and number 3 would be Neymar with a 92 overall score. And the 5 players with most expectations are some unknown players, but they have really good expectations. Expectations is defined by overall minus potential, and this is a variable I created, and this could bring lots of good insights for hiring managers. So enough of exploratory analysis and top 10 facts, and we're going to do something which is quite interesting. We're going to do a Manchester United case study. So let's just present the context. Let's pretend we're part of the Man U recruitment team for next season, which is 2019-2020, and the club wants to sign players in order to compete for the Premier League title. Okay, so there are 4 players that expire contract this season and need to be replaced. First one is Alexis Sanchez, which is a right winger, Mateo Darmian, which is a left back, Juan Mata, right midfielder, and Ander Herrera, which is a center midfielder. Suppose that the club wants to find one replacement for each of those 4 players, plus one central defender to make their defense stronger, since last season they lacked of top defenders. Last 7 years have not been good in terms of performance for the team. Since Alex Ferguson's former manager left Manchester United, the club has not made the best management decisions. Yeah, that is true. Now, with a new manager called Ole Gunnar Solskjaer, the club wants to return to a previous signing strategy, which contemplates the following 4 points. Number 1 is that Manchester United signs players that are not at their peak level but have potential to be elite players. That was the case, if you could remember, of Cristiano Ronaldo, of David Beckham, and Diego Forlan. They weren't superstars when they arrived to the club, but they could perform better as years passed. Contract young players that can be a part of the team for at least 4 years in a great level. So players with less than 27 years old. That is a good threshold. Avoid spending enormous amounts of money, because that may be too risky. There are many examples in the Ferguson era. I can name a few, for example, Falcao or Angel Di Maria, or also Victor Valdés. They were contracted, they were huge players, but they weren't a good fit for the team. They did not perform as good. And the last characteristic is that players that are talented today and don't need more than 1 season to give great performances. So what we're going to do is that we have to bear in mind that we have right now we have a clean data set with 18,000 players, but we want to get a pool with those characteristics. So we're going to get a pool with from the whole data set with players that are less than 27 years old, that have an overall rating of more than 80, which means that they're really good players. They have a potential gap of more than 0. That means that they still haven't reached their potential. The maximum value of what they're going to spend is 80 million US dollars, and the release clause that they have to pay is going to be less than 80 million US dollars. That way they can avoid signing a super expensive player that's not going to deliver on the field, which is exactly what is happening with Paul Pogba. So the cut lines are below, and what I did is for every single player I found their replacement by doing a subset, and returning the player that was best positioned. So this player had to have all these characteristics, and the one selected was the one with the best overall score. And so these are going to be the new Manchester United signings. This would be my recommendation. So it would be Timo Werner, who now plays in Leipzig, Eftoban, who plays in Olympique de Marseille, Jorginho, who now plays in Chelsea, Sule, who plays in in FC Bayern Munich, and David Alaba, who also plays in Bayern Munich. And the total expense would be of $186 million. I put euros, but this is dollars. So last but not least, yeah, I'm going to create some models in order to predict market value, so that hiring managers can have a better idea of what players are actually worth if they take into account the 18,000 other players, and what their characteristics are and what their prices is. So the context: suppose that Manchester United wants to make a model to predict market value of football players in order to assign a market price to their own players, and want to know the market value of players outside the club so that they make the best decision in the next market windows. That way they won't be spending or throwing away too much money to buy a player that's going to under-deliver for the club. So the methodology is that our target variable is going to be a market value, and that is in millions of dollars. So this is a regression model, because in the end we want to extract a continuous variable, we want to extract a quantity, and we are going to use root mean square error in order to get our best models. And in the end, what I did is that I deployed a total of 13 models. Okay, I did some regressions, also did some tree-based methods such as random forest, and I did one super vector machines. But before running the models, I had to do some data pre-processing. I scaled the data, centered it, and selected the features that were going to be used so that our models would accurately predict the value of football players. So this is the whole process I went through, and here are the code lines. So in the end, I ended up with two datasets, one which was non-PCA. That means that it doesn't have a PCA, and a second one which is a PCA dataset. And I tested both datasets, and I got the best result. But before that, I'm going to speak about the data pre-processing step. And part one was the dummification of certain variables that were not in a numerical form. So that way I did the dummification of two specific variables, which is preferred food and work rate. Those were in the form of text variables. And yeah, I filtered my model just to take numerical data. That's another step I did. I dropped near zero variance columns. That's because they are not significant. They don't explain variations that would make our models capture any variance. And Then I center and scale data in order to have data in the same scale, avoid comparing millions versus lower values, and I reduce skewness and reduce highly correlated features, because that may make a model that's going to be misleading and it's not going to perform well on our training data and on our validation sets. And yeah, I also did a PCA dataset that in the end is going to take fewer columns. It's going to take 47 columns as opposed to my non-PCA model, which is going to take 59 features. And the training control, this is the way I'm going to validate if my model is doing well or not, is cross-validation, and I'm going to do a tenfold cross-validation. So this is the whole modeling process. I started with really simple models, which is I started with linear regression, which is the plain vanilla type of model that contains all the features for the non-PCA data. Of course, it didn't perform very well, but the aim was to get more accurate models. So one of the things I did with linear regression is doing models that only took relevant features. That increased the accuracy of my models, but overall what was better was taking a PCA dataset, and that through better performance. I also did stochastic gradient boosting, which is way more complex model, and through better results. I did, so this was stochastic gradient boosting, this was extreme gradient boosting. I did different models. What I did was experimenting with parameters and hyperparameters and comparing if RMSE, which is root mean square error, was getting lower with the multiplications. And so did a random forest also and an SVM, and in the end my best model was an extreme gradient boosting with these characteristics and with a root mean square error of 0.2217. That means that the best this is our best model, and this means that the model has an average error of 721,700 US dollars of error when estimating market value. This is a good model since some players can be worth up to 100 million US dollars while an average player is $5 million. So in the end we provided some great insights of a professional footballer database, and these insights and these models could be used for personnel that are hiring top players, and these can assist decision making to allocate efficiently the resources that clubs have in order to sign players. So I hope you liked it. I hope you find this insightful, and just take a look if you want at my GitHub and at my and all these documents and the whole repository. Thanks.